Okay, welcome back. So today we're gonna talk about persistent storage, and today we're gonna focus on database storage and yeah. So you do remember our awesome product catalog, our awesome shop where customers can right now look at products and like products or vote for products. So we're going to do a couple of changes, and I've actually started to add a little bit of code since we need some kind of motivation for adding some code. So I've added another set of use cases. I haven't actually written them down, but I've written the code for it. But you do remember the current code that either shows a product catalog and creates a link for each of those, and we had some kind of navigation view that made sure that we could navigate to one product, and one product had some kind of unique ID that identifies that product, and we used get, right, in order to find that in our navigation view. So the navigation view's responsibility is to show the correct use case depending on input. So we also had this fantastic persistent solution that saves a value in a file, and we also have some kind of persistence almost in the view that makes sure that a user can only like a product once, and that was done with cookies if I'm not mistaken. Right. So you do remember this one. So I've added a little bit of code just to make sure that we can motivate adding products. So now we're gonna not create these products in a, last time we just faked those, right? We created a product catalog object, we created two objects of the product class, and we added those to the product, and we did that every time the application started. Do you remember? But today we're gonna add products by having some kind of administration thingy. So we can ask the navigation view to navigate us to this really secret admin page. And as you can see, I just changed the URL, and here we had a fantastic, beautiful form where we can add products, and you can see that we can see the current product catalog. More than that, it isn't. We can actually work a little bit. We can write something here, and we can submit, and we can get error messages that are actually wrong right now. I guess I've just copy-pasted the error message somewhere, so we're gonna fix that. No description set, title must be set, so it's actually just the description. And if we add some description, we need to add a unique string, and if we've added a unique string, we need to add a price, right? A positive price. You can see that some of these rules are actually working. And now we added another product, but this product is only added to this product catalog. So if I reload the page without submitting the form again, this product will disappear. So let's do that. So just reload the page. The product is not stored anywhere, so it will disappear directly. So how have I done this? And just to refresh on your, so I've rewritten a bit of the code. Most of the code I haven't really rewritten, but since we now have two main use cases or two main roles that can be logged in, I've added another controller, a master controller, maybe a page controller or app controller, but I call it the master controller because master is cool. So I have two methods on the master controller. Actually, I have three, the constructor, and the first one is handle input, and that must be done before I generate output, right? So first I handle input, and then I generate output. I get a view out of this master controller, and I send that view's HTML to the HTML view. So you sort of remember that part, right? We got a view, and we send that the output to the HTML view. Okay, so let's check the master controller. So in the constructor, we have this temporary code where we create a product catalog with all the fantastic products. And here is the temporary code that creates a few products and adds them to this product catalog. We also create a navigation view. And we had two methods. The first one was handle input. And the first part of that, you haven't seen this one in store before, but you have seen these three lines of code, right? So we created a store controller. We handled input on that store controller. We generated output and got a view back. Now I just save this view in a member variable instead. So let's ignore this admin stuff for a while, and let's just check the generate output. So the store controller itself has not been changed. The navigation view has been changed a little bit, just to make sure that we can select to be in the store or not. So we can check if the admin URL identifier is set or not. So we're in store if that is not set. You might want to have some kind of login, right? If you have an admin interface. You might not want your customers to add products for you, right? But right now, it's sort of safe since we don't store anything. Hopefully, I can add the login code you've seen from Laboration or from assignment 2 into this code until tomorrow, but I'm not sure if I get the time for that. Otherwise, this one has not changed. The product catalog view has not changed. The product popularity view, the product view has not changed. The popularity controller has not changed. So most of the code has not changed. The model has not changed. The product catalog, and product likes has not changed. Still, I added new code to the project, and I added new functionality to the project without changing a lot of the files, right? That is sort of magic. The thing that changed is navigation view, right? Because I need to navigate. I've added a new controller, the master controller, that makes sure that we can select between the admin mode and the not admin mode, right? So let's check the master controller and the part that we didn't see before. So it creates a model class, and it creates a view class for the admin, and it creates a controller for the admin. And it dependency injects these instances together with the navigation view that is not visible here. Sorry. So the navigation view is also sent to the admin controller. We handle input on that. And we actually handle output through this view, right? So I configure what view I'm sending back. Simple, right? So let's check the admin controller. It takes admin facade, takes the admin view. Perhaps it should take this navigation view, since if I'm probably gonna want to navigate in the future and edit products and stuff like that. And I've written a couple of lines. If the admin wants to create a product, we ask for the high-level input of a product from the view, right? Apparently we can get null back, so I must check for that, and then I try to add that product to the model. And if I get an exception, I tell the view that you must display this message that we have a duplicate, because that is the only problem that we can have, a duplicate right now. So the controller at least is supposed to be simple. I have this returning null things and stuff like that, and try catch things, but it's really just, okay, the same thing as for login or for checking products. Does the user wants to do something? Let's get some input from the user in the form of high-level input, and let's do that. If it's okay, if it's not okay, we set some error message. Let's look at the Facade model class, and it's very simple right now. It only contains a sort of encapsulation of this product catalog, and I configure it in the constructor, and I have some add and some get methods here. Do you know what a facade is? Yeah, it's the interface. So an interface to the model. It's a way of saying that instead of all the complicated stuff that I have in the model, the hundreds and thousands of classes in the model, I give a simple interface for the controller to use. So that is why I choose this name. So we like hide complicated stuff behind, and the interface is the methods that we supply, right? So in order to get this working, you need a product catalog to create an object, and you can add products and you can get products. So that is the simple interface, right? Behind that, we could have complicated stuff, and we could have databases, and we could have like rules and communication with other servers and stuff, right? So let's look at the view, and as before, the view contains the more complexity right now. But let's look at this as from a principal point of view, and you don't need to understand every line here right now. So you've seen these private statics before, right? These are the post identifiers. So we have post identifiers, we have some message, and you have seen that before, right? And we have a constructor where we get some model and some view, and we actually create another view here. So a view can use other views to do their thing, right? So in this case, I need a product catalog view, since I'm showing the product catalog. Oh, sorry. Since I'm showing the product catalog below this form. And I have one of these accessors that allows me to ask like higher abstraction questions to the view, right? Admin wants to create a product, returns true if the admin actually pressed the submit button. But I don't mention the submit button. And we also have this more high-level get product that returns an actual model product object that I've created from the input. So I extract some data. I catch some exceptions if there was something that went wrong when I created the product. Oh, I lied. Awesome. I always lie to my students. I actually changed the product class. Sorry about that. In the constructor, I've checked the input, and I return different types of exception if something goes bad. Sorry about the lie. It's just my bad memory. So here I check that the title is a string and that the length of the title is bigger than 0. I might want to check that the length of the title is not bigger than like 100 characters or something like that. And you can see that I've sort of full hacked some ugly hack, some exception classes, subclasses. So I return these exception classes from the constructor, and that way I can make sure that I never create a product object that has some kind of faulty state. So back to the view and the admin view. So I can catch these different exception clauses, and I can set the message. This was done since in my solution for assignment 2, I didn't show this thing with exception, right? So this might be another way of handling errors, so I wanted you to see that one also. You can see that it's just when we don't throw any exceptions that we return an actual product object, otherwise we return null. We might want to like throw that exception further so that the controller that is asking for the product could catch that exception instead. But right now it returned null. I really should have written a comment to tell the future programmer that this method returns two different type of values, null and a product. Okay, we also have the method set duplicate that sets the message, and we have a get HTML, and this one is sort of simple, just creates HTML. Since I had a lot of text fields, I created a helper method or a private method that generates a text field from a title and a name. And it sort of ugly hack here also, since the ID is always the same as the name, and you might want to have several inputs with different IDs but same name, right? If you have an array of objects. But so I saw some code duplication and I wanted to remove that thing. Yes. I also have a helper to get a post field, since this we almost do every time. And I check that it is set, and I also trim it to remove any white spaces. And I can use that one. I should use that one up here, right? So, but I've just written this code, so there are probably more mistakes than this. It would be good to get this trimmed output also. Okay. Any questions so far? Sort of simple, right? So instead of storing products in code, right, like we do right now, we're going to have a database instead. So we need to install a database on our server, and I've chosen to use MySQL, MySQL, someone says, perhaps. And I've also installed PHP MyAdmin on my server. And in this case, it's in my Vagrant virtual machine. It's sort of easy in Linux to do this. You just sudo apt-get install PHP MyAdmin, and you get it installed, and it's even asking you questions if you want to have a password and stuff like that. I actually, since this is run locally, I don't want to remember the password, and this is never going to go in production, right? So my local server is never going to go in production. So I'm sort of don't want a password right now. But PHP MyAdmin nags you about that password every time you start it. So we're probably going to see some red line down here, and they're probably right about it. But these passwords and stuff probably should go in some kind of settings file. And yeah, so how many of you have seen PHP MyAdmin before? 1, 2, a couple, 6, something, 8, 9. Awesome. So this is very commonly installed on web hotels, right? So it's very common, and it's just an easier interface where you can where you can create tables and create databases and perhaps add stuff to the database yourself and stuff like that. So, but we're not going to really start it over here. We're going to start it in code because the approach we're going to have today is that code over data. So code decides over data. So you're in the, and not the other way around. So you don't create your database first, you create your code first. And we've already created our code, so we have these products that are going to be stored. And they have like title, price, unique, description, and stuff like that. Fortunately for us, we had some kind of a requirement that a unique string is needed to create these URLs. And this unique string has some unique properties. They should be able to like exist in an URL, right? So we might want to enforce that requirement also. So maybe like this. So there's a method that you can call on a string that encodes that string into something that can exist in the URL. So one requirement for the unique string that comes in here could be that if it's not suitable for the URL, we throw an exception so that the administrator can create a new string, right? So let's do that one. If what that method returns is not the same as we got in, then there is some kind of character in this one that may not exist in the URL, right? So we throw a new exception. Let's call it unique like that. And if we just add some data here, and we add something that should not be valid in a URL, perhaps a space, I hope that I get this exception, right? So now I got an exception thrown. So now I can catch that and present a good error message to the programmer or the administrator, I mean. So no unique URL exception. Let's go to the admin view. And there's a bug here. And I add another one of these. And we add a readable HTML output that makes sure that the administrator understand the unique string must only contain something like that. We save that and make sure by resubmitting that post. We sort of hoped that we would catch that one, but we didn't. I didn't save it. Who knows? This one was saved. That one is saved. That one is in model namespace. That one is in model namespace. Yeah, maybe if we read this one a bit. Oh, check it out. The Sony. No. Yeah, maybe underscore is not really allowed. Is it? I'm not sure. But that is the one that it's reacting on. So underscore perhaps really is not allowed. I've seen it when we create these URLs that at least Chrome lets us have underscore there, right? But it was actually this code down here that threw us the exception. I'm just fixing the problem and not the error. Okay, this time I guess that I don't understand it. Maybe I've misunderstood how this one works. So Sony string, 6 characters. And the other one is yeah. Thank you, Amanda. The if statement was wrong, right? So it's awesome for you to see that. Something that when you copy paste stuff, like every other if statement up there is a double equal. You can get very blind very fast. Thank you. So I guess that these were not wrong really, or were they? Let's check it out. Recent. Yes, it should be suitable. So underscore is allowed, right? And yeah. Awesome, fantastic. Yes. So instead of getting the products from a pre-created product catalog, we might want to like read these products from the database instead, right? So let's create a database access method that creates these products and allows us to get those products. So do you think that I should create or use this database from the constructor or from the get products? So should I access the database up here like this? Let's say we have a database. Or should I like do it down here? Does it matter? Yes? Mm-hmm. Okay, so yes. So then here, this one, the DB, is sort of a doll class, right? So yes, but the question is, should I access the database in the constructor or in the get products? Right? Should I extract all the products from the database when the application loads, like when the admin facade object is created, or should I access the database when get products is called? in get product, someone says. Repository, someone says. So it really depends. So one way, if we have a few products, it does not matter. Maybe I should extract these products and ask for this product catalog from the database. Okay, I want all the products, and I do that in the constructor. And then I can like have a lot of code that works with these products and calls this get products method a lot, and I just use the local cache, right? So when I've extracted information from the database, I sort of have a copy of the database locally, right? On the server in memory. So if I'm going to use that copy of the database a lot, then I should have it in the constructor, right? So I extract it once, and I use that extracted data a lot. The other way around could be that I extract data, and then I change the state, both locally and in the database, like adding a product. And then I need to re-extract the new set of products from the database, since it's no longer valid. So the copy, the locally stored copy in memory, is not the same as in the database, right? So if this is important, that we have this kind of state maintained, or that the cache is maintained, maybe we need to access the database every time. Sometimes, if you have a really important money transactions, you might want to make sure that these transactions are, what is it called? You've probably read that course much. Yeah, that you complete the entire transaction before you ask again, right? Or if you must complete the entire transaction, right? So it depends on the store. It depends on how you use that data. So one idea would be to extract the data in the constructor once. If I change the data myself, I might want to extract it again in add, since I changed data there. I'm probably going to change the number of products. And then I just use the extracted data in get products. That would be one way of doing it. But it's important to understand that we have this database, and I have my PHP application, and I can sort of get the data out of the oh, awesome. Get the data out of the database, but when I add data to the database somehow, or I change this, I no longer have an accurate copy of that data, right? So it's a cache problem, right? You might want to consider, especially if it's an application that has a lot of users, that you try to keep down the number of calls to the database. Each call to the database, each connection is actually like a phone call, where you need to pick up the phone, and while you pick up the phone, you're using resources both on your own server and on the database server, right? You're keeping a phone line open. So you might want to do that as few times as possible to get a quick response. So I try to open the line to the database once, and then I make every transaction through that line, and then I close it. So we're going to do that. So up here, we're going to need a database. So instead of that, sorry. Yeah. So instead of the product catalog itself, I need a an object of something that can connect to the database. Yeah. So how is it spelled? Cache. C. Like that. And then we just use cache down here. And I can do that as many times as I want. And it does not matter that I get no new connection to the database. I ask no new questions. I just have these. But it's sort of, if you have like, in the beginning down up here, you don't know what data you want to extract. If you have thousands of products, you don't want to extract every product, right? So how much data you want to extract depends on your application, right? So this is just one example on how to do it. And maybe I want to like add this to the database instead of adding it to the local storage. And after that, I might want to extract the data again from the database, right? So this is synchronization. So I add something, a product to the database, and I might want to extract all the products again. Or I just maintain, I do the same changes to both places, both the database and my local storage, or I shouldn't call it local storage, but my cache, and like that. So now I do the same changes to the local cache and the database. So they should still be the same if someone else has not done any changes, right? Okay. So I need a product doll instead. Yes. And yeah, let's take this in small steps. Before we even attach ourselves to the database, I want to make sure that we will actually, if we attach ourselves to the database, I want to make sure that we're actually going to see products. So now I'm rewriting some part of the code to make that happen, and it's actually this one. So maybe I create a local product catalog. I fill it with, I move my temporary solution right now, and I have the same interface as I had before. Like that. And the master controller can no longer create this product catalog itself. It should instead ask the database for it, right? And we create a something like that. We need to include that one. And I'm not sure, it's probably going to break everywhere, but yeah, product catalog master controller line 40. So I'm going to rename that one. DB is not a good name for this one since it's not the actual database. It's just a data access. Okay. I think that we're almost can use that one directly down there and ignore that product catalog. Something like that. And just get this working. Yeah, somewhere in. I still don't have a DB in the admin. This one, right? This doll, and it has no add method yet, right? So I need to add that one also. And still maintaining the illusion that we have a database, I just add this one. Fantastic. So now I've done a refactoring, right? I've not added any new functionality. I've done a refactoring. So what I've done is actually to prepare this previous application for a place to add this database. So I've rewritten it so that it has room for this database. Instead of just adding the database directly, I give room for it first. So and now when we've done that, we see two methods, get product and add, that we must fulfill when we have a database. So let's do that. Maybe not that one here. Okay. So now we want to extract data from the database, but we need some kind of a table in the database, right, to extract the data. And we need some kind of interface to access that, an API to access the database. So the API that I'm going to show you today is called like that, MySQLi, and it's an object-oriented interface to databases, and it seems that PDO is a bit more popular, but I'm going to show you this one since I know it better and have not had time to like relearn the other one. Fortunately for us, there is a lot of good examples on how to connect to databases. So here we can see that in order to connect to that database, we need a server or an IP address to a server or a name of a server. We need a user, we need a password, and we need a database name. After that, we can connect to the database and we can catch errors here. And when we have done that, we can select stuff from the database. So more or less, all this code, we want that code in the doll class, perhaps. But let's start there. So I'm gonna like take all this stuff, copy that, go to my doll class, and just dump it here. So this will not compile, right? But it's a good idea to have like access to a good example. And it's quite okay to like copy paste code, but you might want to rewrite that code to your needs, right? So I'm not going to access the database of world, so I need to rewrite this code. And I try to, yeah, so we're going to do that stepwise. So we can see that in order to start up this application and connect, we need some settings here. We need some localhost, some username. In my case, it's called root right now. We need a password to that database. It's actually empty. And I've created a database already that is called MyDB. But so if you have not, yeah, we need to log in first. Thank you. And here's the error message. You can create a database right here, and you just write its name. Perhaps we should create a new one. Let's call that a store database. And now we have a store database. So let's see if we can connect to that one. And I'm just going to very annoying stuff. Maybe I don't need that one. And you can also see that I need to disconnect from this one. So if, yeah, another line we need. Something like that might work. Yeah, so I'm using namespaces. So this one is not actually called MySQLE, it's root MySQLE, right? Yes. So now it works. The exception I get is that we have an unknown key. Since we no longer have any products in our class, so we get another exception. But we run that line, we've connected to the database and back and close that connection. So can you show how to add the database password to the settings file? Yes, I'm going to show that, but we're not really done here. We're going to do something else before we take a short break. And the thing that we're going to do is like think, okay, this application probably is going to work with more, or going to have more than products in the database. It's probably going to have orders. It's probably going to have these product likes that we've created before. So we might want to share the same connection to all of these data access layer classes, right? So perhaps a better way of writing this would not to create the actual connection in here, but to supply it. So let someone else create the MySQLE connection. Let someone else connect to the database, and let someone else close it. So we're going to move that code out. Yes. So let's take a short break, 10 minutes, 15 past 11. Okay, we're back. So we've decided that it's not a good idea that the data access layer class itself creates this connection to the server, but it needs the connection, so we're gonna dependency inject that one instead. So let someone else connect to the database, like this. And I actually call that one the DB object. So like that, and then I can use that database object in here in this class to access the database, perhaps select all the products from the database, something like that. And now the one that creates the product data access layer class needs to supply one of those. And in this case, it's actually the master controller. So I'm going to use that one. And so in the master controller's constructor, it creates the database connection. It supplies the correct information. We might want to have a settings file with this information. I've shown you how to do that in assignment 2 solution, right? So I'm not going to show you today because we don't want to waste too much time on that. You might want to encapsulate the MySQL connection object in your own class to handle errors differently, or to like have good helper methods. So I usually have a class called like database connection, and inside that class there is a MySQLi object, and it throws exceptions instead of having these print statements and stuff like that. This one is more or less an error that is aimed for the programmer, right? Or the administrator setting up this. So we create one of those, we send it to the data access layer class, and when all input is handled, we close that object. Or maybe after generating output, we close it. The sooner we close the connection, the better. When we've extracted all the information we want to close that connection so that other clients can use that connection, because there is a limited amount of connections, right? So we want to open it, we want to do everything we're going to do with it, and then we're going to close it. Right. And we want one connection. Yes. Okay. Let's see first that this one does not fail. Oh, at least not with that problem. Okay. Now we can use that database connection to extract our data. So, and I'm going to do it in the constructor. And we're going to check how to extract data and how to call things. So you can see that the select question here is actually a call to a method called prepare. So let's use that one also. And I probably wanted to select every product there is. And now I need a name for that table, right? So it's not going to be called city, it's probably going to be called products or something like that. So as the same thing as in the view, where we have string dependencies between HTML and the when we try to extract information from an input field or something like that. We have string dependencies now that is going to be into the database. So in the table in the database, the table itself is going to have a name. That name must be the same as in the questions we ask from the database. So I'm going to have like this from table, and then I'm going to have a private and I'm going to call it products. Up there. The prepare method returns an instance of MySQLi statement class, but if there's something wrong with this this question that I've asked, it will return an error. So yes, and we're going to use that database object instead of that one. So I'm going to throw an exception with that error, like that. And since we don't have a table right now, we have not created that yet, it's a perfect opportunity to check that we do get that exception. Problem is that I call it, I don't know what the problem is. So here it is. Call to undefined. Oh, I didn't call new, right? Throw new exception. Yes. Table store.products does not exist. I might want to have like an assert around this instead, but today I'm just using exceptions for everything. It's a good thing to learn how to use exceptions. So now I have a need for the table products, right? So now I create it. So into the, so let's create a table called products. We're going to need a set of columns. We need the title, the unique, we need the description, and the price. So it's 4 columns, right? So actually, unique itself is a word that you should avoid in SQL, right? So I need another name there. So maybe you've used like PK, have you? Yes? But it's not an integer. Right? So let's create an index for that one also. It's primary index. Yeah. And then we have title. Then we have description, and then we have price. And the price, yes. You might want to use like UTF-8 for these. Yes. And save that one. So in a previous version of this editor, you would actually see the question that created the table, and I used to save that question inside my data access layer class, so that that becomes like a documentation on how to create the class that product data access layer is communicating to, right? But you can use the export function. Sorry for the Swedish in this one. And here you get the create table question. And I'm actually going to save that question in a comment for the product doll. You might want to clean this up. You could even make this data access layer class create its tables if they don't exist, right? Like if you're going to let a user install their application, it's kind of nice that the application itself creates the table it needs, right? So perhaps they need to configure what the database is called or something like that, and these classes creates these tables. It's just a call to a method that you send this question to, right? And if you have this if not exists, you're not going to do any big mistakes like having duplicates or getting errors from that. Okay, so now I have a table, and I can prepare a statement for the table, and then I can execute that statement. It's down here in the sort of documentation. I don't have a parameter that I need to bind right now. I need to execute that statement, and then after that I want the result. So I'm going to fetch the result, bind the result, and fetch the result. Okay. So instead of the district of the city in the example that we had, we want to bind the private key, the title, the other things. So I'm just going to call them private key, title, description, and price. I think that was the order that we've written. And in order to find out, I can check the documentation up here, the query that created the table. PK, title, description, and price. So once again, we have some kind of dependency between the code that I write and the text that I need to write, the order of these. So from that, we can create, we can call fetch first. And when we have called fetch, we're actually going to get one line from the result set. And these variables, PK, title, and stuff, is going to be filled in with information. So when I have that, I can create an product object. And this product object is actually taking title, price, unique description. So here comes like a translation. Between the way things are stored in the database to the way we create objects, right? So this is the main responsibility of the data access layer, to translate, to encapsulate the database, and to translate from the database language or the database storage to objects, right? And to make that, how that is stored, non-transparent. Okay, so now I have a product. Actually, the code will probably not work, right? Because we don't have any products in the database. So we're probably going to need to have some code that makes sure that so I'm going to look at fetch. So we have prepare returns some statement. On statement I can call fetch. So like this. As long as fetch do not return false, I will get another line. So the creation of the products and must be in this while loop, right? Like that, and then I add this to the product catalog. Yes. Okay. Okay. Yes, tack. Thank you. And let's test it first without having any data in the database. It's a perfect opportunity to have that test case done, right? And now we add some data. And yes, the products, the PK, the title. Yeah, I'm going to add actually. The description is just some text and a price. Okay, so now I have one line in my database, a Philips TV, and let's see if we can see that. Oh, I have an error. It's model product, right? Actually, since I'm in the model namespace, I don't need to write it. Yes, fantastic. So now we've extracted this data from the database instead. Okay. So this code, you probably don't want this code in the constructor, since you might want to change how this works, since we've talked about maybe what we want to extract the products in get products instead of the constructor. So this could be a private member that extracts all products. Or we just move things down here. Like that. Now, every time that we call get products, we will check the database for products. Yeah, but I've talked about this cache stuff and stuff like that. So I think you will manage to handle caches. Okay, now we're gonna handle the other case where we want to add stuff to the database instead. So now if I call the admin and try to add stuff, I actually get an error message, right? So why do I get that? It seems to be adding the product, and then it says that I have a duplicate unique key after that. So maybe I'm adding twice or something like that. Am I? Yeah, I am, right. It was the code that I wrote for the admin Facade, right? This one. So I both add it to my cache. Something like that. Yes. Okay. So now we're ready to add stuff, and we need an insert statement instead of a select statement. But it's sort of the same thing as much of what we've done here. We insert into self table yes, and then you have like values, right? Or I got a question like why don't create tables in code? It's much more convenient than to have it created in code. Yes. So it's just really a matter of limited time in the lectures. So it's very easy to have like a query with this statement, so that you create the actual table in code also. So let's go to this one and let's add another line, since I'm don't know my SQL enough. I should sort of feel ashamed about that, but so I add another product, and I just copy this one. Yes. So now the problem now is that I need to put these strings on line 55 should be part of the product instead of these crap strings that I've written. So for this one, I need like to add the product unique, right? I probably need to call the method getUnique or something like that. But here we have a problem with SQL injections. If I concatenate strings and create these strings by string concatenation, I make myself or in the database vulnerable to SQL injections. So SQL injections really means that if someone has been able to create a product with their own title or their own unique or their own description, and they've added a bit of SQL in that, they can actually change the SQL code that I've written. So instead of concatenating strings here, I should use parameterized questions. So I'm just going to clean up this one a little bit. And parameterized questions actually look like this. So you put a question mark where you want to put the data. Something like that, yes. And just like we bound the output to different variables like we did here, bind result, we can bind parameters instead. And that way, the data in these strings, in these title and stuff, are actually sent to the database server and handled not as a part of a string SQL statement, but as separate entities. So the title or the description is not inputted into the string to replace the question mark. It is inputted into the database itself, right? So we can no longer do any SQL injections, and that way we've removed that error. For some of you who has been very cheap when you try to get your web hotel, MySQL is missing from that hotel. And then you need to like escape away all problems instead. So there is a method called MySQL real escape string or something that you can use to escape these strings. Yes. Okay. So now we need to bind these parameters. So let's look at bind param. So bind param takes a couple of arguments. The first one is a string with the different types of arguments. And then you have a mixed set of arguments. So if we take a look at the example, I hope, we can see that they want to send 4 different values. And then first they send a string that tells us what types are these values. The S means a string and the D means a digit or a integer, I think. And then they send the different parameters. So if I send the variables from the product object here, something like this. And I need to do this before I execute the. So I've already prepared the statement. So I have the table, the unique, that it's a string price, an integer. And if you look at this table here, you can see the different types. So D actually means double, I means an integer, and we have a double for price, right? So yes, and there's also blob if you store like images or files in the database. You can use that, or really large texts. So instead of that, we have the PK, and that is the. I'm probably going to do it this way. Like that. PK equals, and now I can extract data from the object that I want to store. And I need to use these something like that. So let's see if we can add this to the to the table, and you can see that now stuff is actually going to be added to the persistent storage, and we probably have them in our database, or I hope so. So we can see how we have 3 lines of crap data. So I'm going to remove those lines, and let's add some better data. So let's say Sony 55-inch description. I don't care about that. A price 10K, unique string Sony underscore some. Oh, yes. So I didn't get an error message, right? Didn't appear below. And when I reload the page, it appeared. So why was that? It was because first I extracted the list of products, and then I added a new product to the database, but did not extract the list again. So, as always, with state changes, you must keep in mind the order, that you change state first, and you might want to read the new state when you create the view. In the data access layer, can we always assume that the in params are correct, that some other class has checked them for potential errors? No, I don't think so. In the data access layer, we should do data validation, but for that type of storage that we have. So if we have file storage, we should, in the file data access layer, make sure that we can save these files without any security problems, that we can create such large files as this data that we have been sent. We should check that no file with that name has already been created. We should make sure that that file is not runnable as a PHP script, and stuff like that. And the same thing goes for databases, right? We should make sure that we are not susceptible to SQL injections. We should check that, let's say, the relationships between the database tables are correct and stuff like that. We do not need to check that a product's title is of a certain length. That is the product constructor's responsibility. Yes? Fantastic. Short of some cleaning up and making stuff more nice, and perhaps documenting and moving settings down to its own files and stuff like that, we're more or less through this lecture. So you've seen how to input things, you've seen how to extract things. There is also update, where you change the state of something, right? And there is delete, where you can remove things. But I mean, this is not a database class. What I want you to remember from this lecture is this. We encapsulate the database. We have data access layer that encapsulate and make sure that no other class in the application is dependent on the database. It's just the data access layer, right? And you've seen that because I've rewritten this application, and I could have this temporary class that had no access to the database, and I made it work with that first. So I can actually remove this database and replace it with a file storage or something like that. And we have some awesome music here. Thank you. So, any questions? No. See you tomorrow.